Hey, this is Dan from userspice.com, and I am so excited to be continuing our series on MQTT and Node-RED. And if you haven't watched the first video, I highly recommend you checking it out. To catch you up to speed, what we have is an Arduino that is sending a random number between 100 and 1,000 over the network via the MQTT protocol. And so all it's doing is simulating you're reading a temperature, you're reading some sort of data. And so right now we're sending that to this little debugger thing, and you can see that what's going to happen is they're coming in every 10 seconds, roughly, you're getting a new message. And so what we're going to do is I've added this one that is just a SQL database. Now, Node-RED can connect to all different kinds of things, and if you want some fun to do some really cool database stuff, you can look up InfluxDB and Grafana, and I may make a video about those things in the future. But right now, we're going to use the more typical SQL database. So what happens is I've added this little node, and I've called the database Pi, and because I'm actually on a Raspberry Pi and I have the MySQL database stored on this, I've just have this from my host, and I've given my username and password, told it what database to use. And now what I'm doing, this node in particular, if you come over here and look at this, it tells you that the message topic, which is basically the subject line, must hold the query, and the message payload is what you're actually sticking in the database. And so for those of you guys that don't know JavaScript, this may be a little bit weird, but what I'm doing is I'm basically writing my SQL query here, and then I'm just passing the message along. And so what will happen is if I drag this over here to connect these two and hit deploy, if we give it a couple seconds, as these messages start coming by, we'll start seeing that if we come here to Pi, right now there's none, but if we keep refreshing the page, we are getting an ID and that random number, and then I just stuck a timestamp on here. And so we're able to record this information in a database. And so there's a lot of different ways to connect to a database, but I think Node-RED is a great bridge for all of your Arduinos. Rather than putting the credentials on the Arduino and trying to find some way, whether sending a GET request or something like that, if you send it all to the Raspberry Pi, then you can have your credentials in one place and feed the information in the database. So you'll see we have 130, 203, 422, and then if we were to come over here and refresh PHPMyAdmin, you'll see that we're getting the data inside the database, and then you can do all kinds of things with it from there. Now, we're not going to spend a lot of time on this, but this function node here, if you drag one of these in here, you can actually write all kinds of JavaScript. So, I mean, you can define variables, and you can do roughly anything that you can do in JavaScript. The one thing to think about is that because these are functions, you basically want to keep in mind the idea that this triggers this, triggers this. So you have this message coming in, and that's the message payload that came in. But you need to return a message so that whatever comes out of this function will go into the next thing, and just down the line from left to right. So anyway, there's plenty of information on there on the web about how to do this a little bit more intricately. But basically, you can use Node-RED to connect your Arduino to a MySQL database. Okay, so we've made it through 6 tips already, but we have not spent a lot of time talking about MQTT. And to me, it is just a beautiful, simple protocol. And so what we're going to do is we're going to look at how these messages are structured. And so what you'll see here is I manage a bunch of buildings in a bunch of places. And so what I like to do with my topics is something like this. So I break it down. This is the state that the building is in. This is the city that the building is in. And then this is the building name. And so if I click on this, you can see that that's my topic. My topic is Florida, Orlando, Building B. And then I just have this set. There's some QoS that basically means how important is this message and whether or not you should save it. I usually put 0 and false. There are some reasons why you may want to change that, but I'm just going to leave that way for now. So what you'll see is if I inject over here, my payload is hello world. Now, I didn't put a topic there, and the reason why I didn't put a topic is because I'm specifying what topic I'm going to publish on here. And so if I were to hit this, you can see that I published a message to Florida Orlando Building B, and I said, hello world. And now what's interesting is, I'm going to drag these out of the way for a second. This thing here is subscribed to everything. This means everything. And so what I'm doing is, no matter what the message says, no matter what the message topic is, we're going to put it here. So if I were to come in here and change this to for Dan only and hit done, then when I publish this message, nothing is going to come over here, because this thing is only subscribed to the topic of for Dan only, and that's not the topic of this message. So what we're going to do, we're going to put this, well, we can actually delete that one. Let's delete that one. And so I want to show you how the hierarchy works. So check this out. So if I were to come in here, let's say that this is a server that's running in Florida, and I want to manage all of the different messages that are coming to all the buildings in Florida, then I can hit this and it's fine, because see, Florida is the beginning of this thing right here. So because I have Florida there, and with the pound symbol afterwards, it's going to receive this message. And obviously the same thing would happen is, let's say I'm in the Orlando Management Center and I want to see all the messages coming to my buildings. If I do this, I'm going to get that, because this one is reading Florida and Orlando. But if I were to come in here and change this to Jacksonville, go Nick Foles, fly Eagles fly, all of a sudden it's not going to get that message. And so the idea is that you can segregate these messages so that you're not sending everything to everyone, and people aren't getting things that they don't need. You can have an Arduino subscribe to multiple topics. So let's pretend that this is what you're sending and this is what you're receiving. It's perfectly fine to say, well, this Arduino needs to subscribe to everything in Florida, but it also needs to be on the emergency channel. So let's say I copy this and paste this and come over here and say emergency. So what'll happen is, when you come over here and drag this, this is one Arduino, basically subscribing to these topics, and I hit this and it's going to get the hello world. But then you can also have it say, let's do this. Let's do red alert. And then we're going to change the topic to, now here's an interesting thing. I'll show you this while I'm at it. If you don't want to specify the topic here, you actually don't have to. You can come over here and put emergency on this one, and then deploy. And now that red alert message comes out over here. And the reason why you may want to do that is you don't actually have to have a whole bunch of these outgoing ones. So in other words, let's say if I take this and so you can simplify your nodes if you come over here and put the topic on whatever sends it. So now I can come over here and drag this one in, and I can come in here and do this one, and let's say that there's a toilet that overflowed. I can do and then I'll do like this. So now code brown comes through over the emergency channel. Everything is just specified in here. So you get the idea that you can have these multiple layers of getting and receiving messages. Okay, so for my next trick, we are going to combine a couple of different skills. And the first one involves copying these nodes. Now you can not only design these things yourself, but you can get them offline where they're sort of pre-configured for you. And I have one pasted to my clipboard right now. So if I go to import clipboard, it's a big JSON array. And so I can come in here and I can drag that anywhere I want. Now, if I were to come in here and just add something to it, and I want to export this to share it with somebody else, then I highlight whatever I want to share, and I hit Control-C, and it copies those nodes, and I export to clipboard, and then I can click that, and now you'll see if I delete this and import in the JSON array I just copied, I'll have all four things. So these things are very shareable. And so what I want to show you is I like to use Node-RED to play sound, and you can do it straight from Node-RED. I tend to like to do it over PHP. I think it's a little bit quicker. There are different nodes that you can use to play sound with the Raspberry Pi itself, but I have a bunch of PHP servers set up. So one thing I like to do that you can use in basically any way you want is I have this one called HTTP request, and it's a standard one that's built in. And so you can come on here and I can say, all right, I want to go to the server at 148. I want to go to this folder, and then go to sound.php and play sound equals laser. And so real quick, I'm using the UserSpice framework, obviously. But basically what I'm doing is I'm coming in here, I'm sanitizing the input. And this is kind of a cool line. So basically what happens is it looks to see if I'm on Windows. And if I'm on Windows, there's a file in that directory called cdmp3.exe. If I'm on Linux or Mac, you can do like sudo apt-get install mpg123. And basically it can tell which operating system it's on, and it'll use the appropriate player. But then if I were to come in here and all I'm doing is, so I think that other one was like laser. So if I come in here and laser, it's going to go to sounds good and laser.mp3. So what I do, my security cameras have the ability to send out an MQTT message. So when somebody's at my front door, I take that message and I send out an HTTP request. And that HTTP request goes to the server and tells it sound.laser. Now we can trigger that manually by just injecting anything in there. And you'll see, I mean, this is going on a different server in my network, but it's pretty instantaneous. And, I could come in here and change that to hit or whatever and play a different MP3 file. And so you're going to get that little, splat sound. And so it isn't particularly about sounds. I really like using this way for sounds because there's really no load on the Raspberry Pi, and the other servers are running all the time. But the big thing is you can do any kind of PHP requests. You can do GET requests, you can do POST requests, puts, all that kind of stuff, and you can you can do them over HTTPS, and it's just a really cool thing to be able to interact with other servers over Node-RED. And so going back to what I said in the first video, your Arduino Uno and Mega and Nano and all those things cannot do HTTPS. But if I was going out to a live server, the Node-RED has no problem making that as an HTTPS request so that you can take the insecure data that's going over your own network and send it securely to a public web server. The next thing I want to talk about is the idea of timing. So many people want to design things like automation systems, and people are trying to come up with all these organized ways to have time, and they're adding real-time clocks to their Arduinos and trying to decide when their sprinklers are coming on and all that kind of stuff. And there's a better way to do it, and I believe that Node-RED is the better way to do it. This guy is a legend. I don't know if you know Peter Scargill, but he is a legend, and he created this thing called Big Timer. And I'm not going to do a lot of installing on there, but if you go to his website, you'll see that there's all kinds of different things that this thing can do. And you could basically trigger your devices to stay on for a certain amount of time. And there's just all kinds of information that you can do, really super complex timing things. And you can use Bluetooth, and you can use MQTT messages, and this can trigger that. And there's just all kinds of sweet timing things you can do here. In addition to that, there's a couple of other built-in things. And so let me give you an example. So if I were to come in here and let's just say inject, and I'm just going to inject a 1. And if I were to come in here to this, let's find one called trigger. Okay. So if I were to come here and do that, and then we'll get a debugger going on. And we will get to our debugging node and tell it to only show us what's on this flow. And I'm going to clear everything out. Now what I'm going to do is I'm going to drag this to this and then we're going to click on this, and you can say we're going to send a 1, and then we're going to wait 1 second, and then we're going to send a 0. And you can keep repeating this stuff. You can resend. I can come in here and say resend every 1 second. So like if I were to come in here and deploy now, current flow. Okay, yeah, I have something going on with the certificate. So basically, every second it's going to send out a 1, and there's all kind. Obviously, that's not something you're probably going to do, but one of the interesting things is that nothing happens there until that thing is triggered. So now that I took this out of the way, it's not going to do anything. But once I connect it, it'll keep triggering. But basically, there's all kinds of different ways to build timers and triggers, and you can have a message come in and have a delay on it before something else happens. So let's say you're opening up a door and you want to release the magnet for half a second and then send the message to rearm the magnet. There's just all kinds of things that you can do in here. And one of the neat things about this, and I believe I said this in the last video, is that let's say you're deploying these things as IoT devices, and you decide all of a sudden that quarter-second delay that you put in there was not long enough. Well, if you deployed 50 of those things, you'd have to push the code back to every single one of them. You have to physically get to the Arduino, plug it in the USB port, or use one of the over-the-air updates. But with this, you have a web-based way of changing that timer. And so you can go from a fixed delay, random delay. You can do all these things that would be just more work to program in the Arduino. And the cool thing is that once you have it on here, you can modify it once, and every Arduino that visits this thing will get the benefit of that. Okay, so up until this point, we've basically been trying to have our Raspberry Pi or our Node-RED or MQTT server interact with other devices. But what if we want to interact with the actual pins that are on the Raspberry Pi itself? If I were to come down here, I can come to this one, and I'm going to make this, I'm going to grab this, and I'm going to show you, we'll take an inject over here. So if I were to come over here and double click this, all of a sudden you get the 40 pin GPIO pulled up. And I'm going to just select one down here. They have this weird numbering system. But so this is pin 31, which is also known as GPIO 6. And we're going to tell it that it's an output. And by default, we're going to have it off. And we're just going to call it LED. I could be cutting over to an LED in the video, but that's just kind of pointless. I think you guys believe me that it's actually going to work. If you don't, comment below, and I don't care. So anyway, I'm going to take this and I'm going to make a 0, which would turn the LED off, and I'm going to make a 1 that would turn the LED on. And now what I can do is drag this in here and click this and drag that to there, and now I can go back and forth and I can turn the LED on and off at will. Now that's not super impressive, but you have these 40 pins, and a lot of them can do cool things on the GPI on the Raspberry Pi. So why not use them? Let's say you have something that is pinging to see if the internet is up. Maybe you want to just have something, a light turn on telling you that the internet's down. Or maybe, let's try this. What if you wanted to, let's go to our other flow here. We have all of these messages here. All right, let's try this. I'm going to take this. This is a live experiment. I'm going to paste this down here. And now, let's say that every time a message comes in with emergency, we'll copy this up. Every time a message comes up with the topic of emergency, then we're going to use this trigger node thing that we played with earlier. So we're going to come in here and we are going to trigger this with a 1 and then wait for it doesn't matter. Let's wait for half a second, and then we're going to send a 0. And so I'm going to click this in here, and we'll go ahead and turn the LED off to begin with. And let's see. So the LED's off. If I were to come in here and hit Hello World, that's not going to trigger the LED. Let's drag this down here so you can see it a little bit better. Hello World doesn't do anything, but emergency turns the LED on. And so you could have something where, like, maybe you want to know that an emergency message came through, and you might even have that repeat over and over and over again until you come in and acknowledge the alarm that an emergency thing has happened. And so no matter which one of these happens, that LED is going to flash. And so that's cool. I mean, you have the GPIO pins, so why not use them? So it'd stand to reason that if you're going to be able to do the outputs like that, you should actually be able to do the inputs. And you'd be right. So I could double click on one of these and I could say select GPIO 4, which is only allowed to be an input. And I can say if I have a pull up resistor or pull down resistor, you can set the debounce. So like it doesn't think the thing has been pressed multiple times, like maybe it only allows you to press it once a second or something like that. But let's say that this is an emergency button and you want to send out a message. So emergency button like that. And then we're going to take that and let's make sure that's right. Digital input is support. Okay, great. So now what we're going to do is we're going to go to this one called change. I think would be a good place to go. And basically this doesn't have any kind of topic so that we could MQTT it out. So what we're going to do is we're going to set the message topic to emergency. And then we'll add another one. And we're going to set the message payload to button pushed. Okay. Now, what we can do is take that over here. Well, we can actually just connect it to this existing one here. And whoop, like that. And then what would happen is we're gonna trigger this with a trigger node, since I'm not going to physically push a button. It's in a different room. So if I were to deploy this, then what happens is if we pretend that this is the button on the Raspberry Pi, when I trigger it, you saw that this thing, the trigger node over here, fired. So I pushed this, it changed the topic to emergency, sent it out. This thing read the topic of emergency, turned the LED on. So you could see how that works in both directions. Now there's a lot of other things. If I were to come in here, it's been a while since I've looked at this, but if I were to come in here and do DS18B20, you can see that there are nodes in here that are specifically designed for things like typical sensors that you would use on Arduinos or Raspberry Pi. If I put DHT11, I'll bet there's one for there too. Yep, so if I take this one and install that, I've got these are the two most common old school temperature sensors on Node Red. So if I were to come in here, they would be in here somewhere. Let's see. Okay, so I would have this D18B20. You would double click it and it would read whatever one you had attached to you, or there should be another one called DHT where, let's see, they are a little hard to find when they first get installed. They're usually at the bottom of the thing, so let's look. I honestly have no idea where that DHT one went, but oh, there it goes. It just installed. DHT22. So you can come in here and you can give it a topic, and you can tell if you're reading a DHT11, and then you tell it which pin you're in, which pin you're on, all that kind of stuff. You can choose which GPIO pin, and basically you could say you could hook this up to one of these trigger nodes where every so many seconds you're going to click this thing and you're going to take the information from the sensor and shoot it out to MQTT. So again, I'm just scratching the surface, but if you Google the different sensors and the things that are available for Arduinos and Raspberry Pi, a lot of them can be connected directly to the Raspberry Pi and read in Node Red. So I hope this gets you interested in the different things that you can do with Node Red and MQTT. It really is the glue that holds all of your different devices together. I can bring in messages from my security cameras, my Arduinos, ESP8266, ESP32, other Raspberry Pis, my PHP server, all kinds of different things can interact with these things and just really make all of your IoT stuff work together. And the cool thing about it is you're not dependent on a third-party service. This is your stuff. You own the Raspberry Pi. You get to decide who can access it and who can't And so, anyway, I hope you found it interesting. If you did, subscribe, like, hit that little bell for notifications, and I'll catch you next time.